lot of, and we did it a little bit first semester here and there, is we haven't talked a lot about what the graphs of the functions look like. Okay. So this actually isn't an algebra 1 thing, it's an algebra 2 thing. All right. So we're going to kind of fill in a few of our algebra 2 gaps that we've had that I've missed along the way, because we do have to get to the trigonometry piece, because that gets us to being able to take calculus next year, because that's the whole point of this class, is to be able to skip ahead a little bit. Okay. So I'm going to graph this really quick just in Desmos so that you can see what it looks like. We're going to work on rational graphs, and we're going to see this again and play with it in Desmos later in the week. But there's some things in graphs that sometimes we don't all see but are there. Okay, but just so you can see what a rational graph looks like. So let me get into Desmos. It was x plus 2 in the numerator, and I can't remember the denominator. X squared minus x minus 6. So x squared minus x, was it minus 6? Is that right? Yeah, okay. So that's what a picture of a rational expression looks like. It's usually got two what we call branches, okay? And then it has two what we call asymptotes. It has one right here. An asymptote is something that a graph gets really, really close to, but it never crosses, okay? So it has a horizontal asymptote here. We're going to talk about horizontal asymptotes next week, but it looks like it kind of has an invisible line right here that it's never crossing, and that's what we call a vertical asymptote. Sometimes you'll see them drawn in with like dashed lines. And then the other thing that could be there is sometimes there's places in our graph that have holes, okay? So I'm going to put in an f of x equals here. So we're going to come back to that in a minute. We're going to talk about where we have asymptotes and where we have holes, and we'll look specifically at that function in just a minute, okay? So a hole in a graph is when, usually what we do is we factor things, right? Looking at that denominator, it definitely is something that is begging to be factored, right? So when we have something, when it factors and we're rational and it cancels, if it cancels, it's a hole, okay? Whatever is left behind in the denominator, we set it equal to 0, and that is a vertical asymptote. So this is what's left behind in denominator, set equal to 0. And really what you're canceling, you're also setting equal to 0. A lot of that, though, we kind of can do in our heads, because we can flip a sign in our heads a lot of the time. All right. So let's take a look at number 1. And this is yet again a sneaky way to review factoring. Okay. When it comes to the SBAC, or some of you are taking ICAs because you're 10th graders, you should not be getting the factoring wrong, right? We've done it 5 million times this year. Okay. So you should be able to do that part of the test. All right. Without a question. All right. So I'm going to factor just the denominator because the numerator has nothing to be factored, right? So I'm putting a -6 in the top and a -1 in the bottom. I didn't even ask you, it's a trinomial, so we're doing magic x, right? So what two numbers multiply to -6 and add to -1? What do we get?
-3 and 2.
-3, +2. Everybody good with that? Okay, so I'm going to rewrite this guy over here. So f of x equals, I've got an x plus 2 in the numerator. And do I need a box this time? No leading coefficient. So we're going to just go with x minus 3 times x plus 2. Okay. We notice something that happens, though, because we've done a unit on rational expressions, right? We did that before Christmas, right? So what ends up canceling? And that always made us feel really good, right? To cross stuff out, right? So we just canceled something. The problem is we can't just cancel it and just forget about it when we're trying to interpret it with the graph. So we know that there's a hole. We take that x plus 2 and we set it equal to 0. So there's a hole at x equals -2. So I'm going to show you that on the graph in just a second. All right, and then let's write down what's left. Technically in my numerator, what number is left up there? Good, it's a 1, not a 0. It doesn't go away. And your x minus 3 does not move upstairs all of a sudden, okay? We've got x minus 3 down in the bottom. What's left behind is what we consider a vertical asymptote. So I'm going to take what's left behind, vertical. And you see how funny it's spelled? I can never spell it. Like the ASY, and it's ridiculous. So I just abbreviate usually. Vertical asymptote. We've got x minus 3 equals 0. I don't know who came up with that word and how to spell it. All right, x equals, what do we end up with? Positive 3. When you're listing your answers in Otis this week on Friday, you need to have x equals. And I'm not going to put that there. You'll have to have it there. What's wrong? Basically, yes. Yeah. So does everybody see that observation? Really, ultimately, what you're doing is that was a positive 2. You switch the sign over, right? This was a negative 3. You switch the sign over. Where you have to be careful is if, say, it was like 2x plus 1, you can't just switch the sign, right? Because you're going to have to divide by a 2. So just be careful. It's safest to set it equal to 0, but it is a sign flip most of the time. Okay, let's look at that on this graph, okay? Just so you can kind of put the two things together. So I'm going to graph x equal to 3. You see how it's that asymptote right in between. Usually, let me see if I can get, oh, not that. There it is. Usually you make it a dashed line. So it's not really part of the graph. It's an assistant to help us draw the graph, okay? Now, if I evaluate this guy at negative 2, look at what happened. It says that it's undefined. That's because when I substitute that in there, I get a 0 in the denominator, okay? Same thing if I evaluated f of 3. I would get that it's undefined. Even though our graph shows at negative 2, look at right there at negative 2. Doesn't the graph look like there's something there? No matter how much I zoom in on it, it's not letting me zoom more. No matter how much I zoom in on it, your graph basically takes and factors it out already. So like never shows the whole, even though it's there. So there's kind of invisible, but it does exist. Okay. All right. So we're going to try this again a little bit faster. Okay. Look at number 2. So I want to find holes in asymptotes. What do I need to do first with the denominator? Factor. What kind of factoring is that going to be? Okay, I heard squares. What kind of squares? Not square roots. There's another word that goes in front of it. Difference of squares, right? Okay, so difference of squares factoring. And that means I need to take the square root. So the process is taking the square root. What's the square root of x squared? X. Okay, what's the square root of 16? 4. Make 1a positive and 1a. Yeah. Grab one out of there. Okay. All right. What do I need to do now? What's our instant kick going to tell us to do? Cancel some stuff out, right? When I cancel stuff out, what is that considered? A whole, right? In terms of our graph, our whole. Okay, so at x minus 4 equals 0, or at x equals what value? 4. Good. Okay, and then I'm going to write down what's left behind. So I've got 1 over x plus 4. So when I have stuff left behind in the denominator, what do we call that? What's on the graph? An asymptote, but not just an asymptote, but a vertical asymptote, because next week, remember, I told you you're going to have a horizontal asymptote. We're going to get that a different way. So vertical asymptote, okay? So I'm going to set that denominator equal to 0. So you end up with x equal what? Negative 4, okay? So what we're going to focus on is just the algebra behind how to find those values on the graph. We're going to see a Desmos later in the week. It's going to help do the graphing with us, okay? All right, I want you guys to try number 3 really quick. So everybody's trying number 3. Okay, let's look at it together, okay? So what did you do with your denominator? Factor with a what? The good old magic x. Okay, so I have f of x equals x plus 5 over. All right, 2 numbers that multiplied to negative 10 and added to 3. What'd you get? 5 and negative 2. So x plus 5 times x minus 2. All right, what happens next? Just 5? X, but you got to be careful, right? Because remember, you can't cancel over the plus signs, right? That's where the killing kittens thing comes in. We don't want that to happen. All right, when I cancel it, what part is it on the graph? A whole. Good. So I'm going to do X plus 5 equals 0. So X equals what? -5. All right, then I'm going to rewrite it out. So I've got 1 over X minus 2. When it's left behind in the denominator, what do we call it? Vertical asymptote. Okay, and I'm going to go X minus 2 equals 0. Set that denominator equal to 0. So X equals 2. I will tell you, we didn't see it here, but you can have more than one whole and more than one vertical asymptote. Okay, it's possible. I kept it really simple just to make sure we understood it, but there's a possibility that you get more than one of those things. Okay? All right. That's it on the skills check. I want to really quickly